Hi, today we're looking at Functional Skills Maths Level 1. We've got the City and Guilds exam board. This is past paper 2 and we're going to start with the non-calculator section. Question 1. 3/4 times 3,600. Okay, so what we can do to start with is think of this as 3/4. So if we work out 1/4 first, in other words, we want 1/4 of 3,600, which is the same as 3,600 divided by 4. Or if we do that using the bus stop method, 3,600 and 4 on the outside. 4 doesn't go into 3, so we try 4 into 36. 4, 8, 12, 16, 20, 24, 28, 32, 36. That's 9 times. 4 into 0 goes 0 times. 4 into 0 goes 0 times. So we've got 1/4 of 3,600 is 900. We want 3/4. So we want our 900 times 3. So 3 times 0 is 0. 3 zeros are 0. 3 times 0 is another 0. And 3 times 9, 9, 18, 27. So we get a total of 2,700. Question 2. What is 0.05 as a percentage? Because if we want to turn it into a percentage, we need to multiply it by 100. So we've got 0.05. Multiplying it, so we're going to be moving the decimal point to the right and multiplying it by 100. So 2 zeros to move the decimal point once, twice. So we end up with just 5%. Question 3. 30 squared. So that means 30 times 30. Well, let's ignore the zeros to start with. I'm not cancelling them, I'm just ignoring them. So I'm going to say 3 times 3, 3, 6, 9. And then we put the 2 zeros back on. So we end up with 900. Question 4. A student makes the following calculation. I'm going to put my comma in here so I can read it more easily. 20,000 divided by 50 equals 400. Show how the student can check the answer using reverse calculation. So reverse calculation means we start with the answer. So we're going to start with the 400. And we did a division. So the opposite of division is multiplication. So we're going to do a times. So instead of dividing by 50, we're going to multiply by 50. And that should take us back to 20,000. And we can check that because we can say we'll do the 4 times 5, which is 5, 10, 15, 20, and then put 1, 2, 3 zeros on the end. Question 5. What is 27.191919 rounded to 1 decimal place? Well, that's our first decimal place. So we look at the digit after it, which is the 9, if I'm pointing clearly. If it's 5 or more, we need to increase 1 to the previous number. So that is going to become 27.2. 1 decimal place. So we've got 1 decimal place in the answer. Okay, question 6. If we can fit all our options on here, yeah. This triangle shows the side lengths, but not the angle sizes. So we've got from A to B it's 7 centimetres, from A to C it's 13 centimetres, and from B to C it's 18 centimetres. Which angle is the smallest? Okay, well, you can look at the diagram here, but as it says, it's not to scale, so it's not necessarily going to be the most accurate thing. But if you think about the length of the lines coming off it, the smallest angle is going to be the one with the 2 longest lines coming off it, because they're going to be going further before they reach this steeper line over here. So this is going to be smaller than either of those two. So we can say it's angle C. Question 7. Minus 45 plus 31 equals. Right, so let's draw a number line. We're going to have 0 here. We're going to have minus 45 here. And we want to add 31. So we're adding, so we're going this way by 31. So this 45, well, it's minus 45. But if we just think of the 45 bit, it's going to get smaller. Because 31 isn't going to be enough to take it all the way to 0. So it's still going to be a negative number, but it's just going to be less negative. So we can say, well, let's do 45 minus 31. 5 minus 1 is 4. 4 minus 3 is 1. So it's going to be minus 14. So if we add on 31, we'll get minus 14 up here. Question 8. Which one of these lists of percentages is in decreasing order? So decreasing means getting smaller. For 1% to 10%. That's increasing, so that's no good. 1% going up to 11%. Again, that's not decreasing. 100% down to 10%. That's good, that's decreasing. But 10% to 11, well, that's going up. So that's not decreasing. Hopefully D is going to work for us. We've got 100%, then 11. So 11 is less than 10. Sorry, 11 is less than 100. 10 is less than 11. And 1 is less than 10. So these are all decreasing. Question 9. 6 plus 18 divided by 3. So we need to remember our order of operations, which says that we do our division before our addition. So we're still going to have the 6. We're not changing the position of it. It's just that we're doing this part of the calculation first. So 18 divided by 3. Well, let's do our 3 times table. 3, 6, 9, 12, 15, 18. So that's 6 times. So we've got 6 plus 6, which gives us 12. Question 10. Increase 1,600 by 25%. So the first thing we want to do is work out 25% of this and then add it on. Well, 25%, hopefully you'll recognise that that's the same as 1/4. So let's work out 1/4 of 1,600. So we're going to do 1,600 divided by 4. 4 into 1, 4 can't go into 1 because 4 is bigger than 1, so we try 4 into 16. And we've got 4, 8, 12, 16, that's 4 times. 4 goes into 0, 0 times, and 4 goes into another 0, 0 times. So we've got 400, and we're increasing 1,600 by this, so we're going to add on the 400 to the original 1,600. 0 plus 0, 0, same again. 6 plus 4 is 10, and 1 plus 1 is 2. So we get a total of 2,000. Question 11. A bricklayer is building a wall with old and new bricks in the ratio of 3 to 1. He needs 1,200 bricks altogether. How many new bricks does he need? Okay, so we're going to draw a little ratio table for this one. So we're going to have old bricks, new bricks, and total number of bricks. We know the ratio is 3 old for every 1 new. So if that's all we had, 3 plus 1 would have 4 in total. But we're told we've actually got 1,200 bricks in total, or altogether. So we want to know how we're getting from this first row up to the second one. So we do that in reverse. So we say, well, let's do 1,200 divided by 4. 4 can't go into 1, so 4 into 12 goes 4, 8, 12, 3 times. 4 goes into 0, 0 times. 4 goes into 0 again, 0 times. So we're multiplying the first row by 300. Now we're only interested in the new bricks, so we can just multiply 1 by 300, which anything multiplied by 1 is itself. So we're going to have 300 new bricks. Question 12. This is for 3 marks. A bank advertises these interest rates for savings accounts. Okay, if the amount is up to £1,000, the interest rate is 1%. If it's between £1,001 and £5,000, it's 3%, although it says you may not take out any money for the first year. If it's between £5,001 and £10,000, the interest rate is 4%. Same thing, you may not take out any money for the first year. And over £10,000, interest rate of 5%, you may not take any money, not take out any money for the first year. A couple put £12,000 into one of these savings accounts. How much will they have in the account after a year? Now this bit about you may not take out any money for the first year is a bit of a red herring, because they're saying how much will you have in there. So we can it doesn't mean anything, it's not adding to it. And that's what it's important to see, what information is relevant and what isn't. So this asterisk and this bit, we can ignore that. So we're just trying to increase £12,000 by the relevant interest rate. So if it's £12,000, it's over 10,000, so the interest rate is going to be 5%. We're not slicing it up into sections that some at this amount and some at this amount. It's going to be 5% for all of the amount, which is the full £12,000. So for us to work out 5%, what we can do is first work out 10%. And I know if we want 10%, we just take a 0 off. So it's going to be £1,200. If we want 5%, well, 5 is half of 10, so we just want half of this. So let's do that over here. 1,200 divided by 2. 2 can't go into 1, but 2 into 12 goes 2, 4, 6, 8, 10, 12. That's 6 times. 2 into 0 goes 0 times, and 2 into 0 goes 0 times. So 5% is going to be £600. So it started off with £12,000. They get £600 interest. So we'll add these two together. 0 plus 0 is 0. Same again. 0 plus 6 is 6. 2 plus nothing is 2. 1 plus nothing is 1. So our answer is £12,600. So now we're onto the calculator section. What is 3/5 of 865? So I can go straight to the calculator. 3/5 of 3 divided by 5 times 865 is 519. Question 2. What is the volume of this cube? Well, a volume of a cuboid is the length times the width times the height. Because this is a cube, they're all the same. So it's going to be 25 times 25 times 25, which is 15,625, and they've already put the units in centimetres cubed. Question 3. List the following numbers into ascending order. I'm going to put my commas in here to make it easier for me to read these numbers. So we've got 705,280, 710,046, 700,955, and 707,000. That's it. Now, because all the hundreds of thousands are different, I can kind of ignore the tail bit and just look at those first digits. So we've got 705, 710, 700, 707. So this is the smallest one. 705 comes next, then 707, and then 710. So we just need to write these in the boxes. And there we go. Question 4. What is 990,099 in figures? So I'm going to ignore these to start with, and we're going to try and just write it out. So 990,000. So 990,099. Now that looks a bit weird because we've only got 2 digits after the comma. So what about hundreds? Well, we haven't got any hundreds, so we put a 0 in there. So 990,099. Hopefully this is one of the options. There it is. Question 5. Which one of the following is the highest temperature? Okay, well, we've got one that's 0, the rest are negative. Well, if they're negative, they're all less than 0. So that one must be the highest. Question 6. A customer asks a builder to paint a garage floor. The customer says that the area of the garage floor is 16 centimetres squared. The builder says that this must be wrong. Is the builder correct? Explain your decision. 16 centimetres squared. Well, this is clearly wrong. And the reason for that is because if you think centimetres squared, well, for it to be 16 centimetres squared, it could be, well, 16 is 4 squared. So let's draw a little, where should we draw it? Draw it up here. So this is actually a scale drawing on here. That's 4 centimetres, 4 centimetres. So this is 16 centimetres squared. To scale. So we can put clearly too small. Yeah, it's quite hard to explain it without just drawing and saying, look at this. What we could put is the customer may mean 16 metres squared. Oh, I can't spell instead of 16 centimetres squared. We could also say this is a garage. Yeah, I think that's probably enough. It's a slightly awkward question to answer, I think, but it is only 1 mark. So we don't want to spend too much time on it. Question 7. The picture shows a worker at their computer and the angle of their vision looking at the screen. Okay, here's the angle of vision. So we can do that to make it look like an angle. Health and safety recommendations for workers looking at computer screens say the minimum angle of vision is 15 degrees, the maximum angle is 20 degrees. The dotted lines on the diagram below show the worker's angle of vision at their computer. So where we drew that little arc, it's in there. Does the worker's position meet the health and safety recommendation? Explain your answer, include figures to support your decision. So we've got 2 marks for this. So what we want to do is work out what the actual angle is. So we're starting here at 0. Here's 10. That would be 11, 12, 13, 14, 15. And I would say that's about 17 degrees. Well, 17 degrees is in between 15 and 20 degrees, so that's all good. So now we've just got to turn that into a proper answer. Does the position meet recommendations? Yes. Explanation. The angle of vision is 17 degrees, which is between the minimum and maximum angles of 15 degrees and 20 degrees, something along those lines. Question 8. A woman wants to buy a flat in a block in the centre of town. She has up to £85,000 to spend. An estate agent has these flats for sale. Okay. We've got the flat number, what floor it's on, number of bedrooms, whether it's got a parking space, and the price. The woman wants a flat with 2 bedrooms and a parking space. She wants to be on the first floor or higher. Find all the suitable flats for the woman. Which flat do you recommend? Okay, so we've got quite a few criteria. The first one was that she has up to 85,000 to spend. So I'm going to write that in digits, 85,000. So I'm going to go through each of these, and anything which is more than 85,000 she can't afford. So these would all be all right. This one's going to be too much, so ignore that. So is this one. 86, 90,000 is going to be too expensive, and 95,000. The others are okay. Now, what was the next condition? Needs to have 2 bedrooms. So, flat number 1's no good. That's 1 bedroom. That's no good either. Flat 5's only got 1 bedroom. So it's flat 6. Oh, and flat 10. And say goodbye to you as well. Okay. Also needs to have a parking space. This one hasn't got a parking space, so we can say goodbye to flat number 3. Any others? This one. And flat number 14. And then also it needs to be on the first floor or higher. So anything on the ground floor is out. So let's see what's left. 1, 2, 3, 4, 5, 6, 7 all ruled out. We've got flat 8, 9, 10, 11, 12, 13, 14 ruled out, and 15. So find all the suitable flats for the woman. Which of the flats will be suitable? 8 and 15. Then which one do we recommend? Well, this is sort of up to you, as long as you can give a good explanation. So I'm going to recommend flat 15. And the reason I'm going for 15 is just because it's a bit cheaper. So she's got more money to spend on other things like furniture. So explanation, flat 15 is cheaper than flat 8, so she will have more money to spend on furniture or a housewarming party. So that was for 3 marks. Question 9. The manager of a vet's practice checks how long owners had to wait with their pets to see the vet last week. So we've got the total number of pet owners for each day, the minimum time they waited, and the maximum time they waited. The vet wants to talk to a pet owner. She chooses one at random. What's the chance that she picks someone who has waited more than 5 minutes and waited more than 30 minutes? Or waited more than 5 minutes? Well, the minimum time is above 5 for all of them. So it's absolutely certain that they waited more than 5 minutes. We also want to know the chance that someone waited more than 30 minutes. Well, the maximum time people waited was 17, 29, 25, 20 and 28. Those are all less than 30. So it's absolutely impossible that someone waited more than 30 minutes. So they then say explain one of your answers. So we don't have to do both of them. So you can pick either one. So I'm going to say go with the maximum. And just say the maximum wait time on every day was less than 30 minutes, so it is impossible that anyone waited more than 30 minutes. And that was for 3 marks. Question 10. A man gets a new job. He will earn £10.75 an hour. He will work 39 hours a week. He wants to know how much national insurance he will have to pay in a year. He finds this help online. To work out your national insurance for a week, subtract £166 from your earnings for the week, and then multiply the answer to step 1 by 0.12. So, we want to work out the earnings for the week, so we can subtract 166 from it. So we need £10.75 per hour multiplied by the number of hours worked. £10.75 times 39 is £419.25 for the week. We then need to subtract £166, which gives us £253.25. Then we need to multiply that by 0.12. So 253.25 times 0.12. And I'm leaving my previous answer in my calculator each time. And that's £30.39p. Now that's for 1 week. But he wants to know for a year. So we then need to multiply that by 52. 52 weeks in a year. And we get £1,580.28. And we'll just transfer that down to here. They've already given us the pound sign. And that was for 3 marks. Question 11. A company puts computers in packing boxes to send abroad. They want to pack as many boxes into a shipping container as possible. So here's our big shipping container. We've got the measurements here in meters. And here's the packing boxes. And these measurements are all in millimeters. And it says this way up, so we can't rotate this, it's got to be this way round. What is the maximum number of packing boxes that will fit in one shipping container? Okay, so we've got meters and millimeters. We want to turn them all into the same units. So what I'm going to do is I'm going to turn my meters into millimeters. And first of all, I'm going to turn them into centimeters. So there's 100 centimeters in a meter. So multiply that by 100. So 6 times 100 is going to be 600 centimetres. And then there's 10 millimetres in a centimetre. So multiply that by 10 to give us 6,000 millimetres. So we can do the same with these. So I'm going to multiply it by 100 to get centimetres and then multiply it by 10. So if we do that with the calculator, 2.5 times 100 would be 250 centimetres times 10 gives us 2,500 millimetres. Same here, we'll multiply it by 100, then multiply it by 10. You could just multiply by 1,000, but I find it easier to think of it step by step, changing to centimetres first and then millimetres. So 2.6 metres would be 260 centimetres, which is 2,600 millimetres. Okay, right, so you might be thinking, this is a volume question, work out the volume of this and the volume of that. That's not necessarily going to work. It might work, but there's a chance it won't, because this box needs to be this way up. It's got to stay in that position. So instead, I'm going to think of this shipping container. I want a plan view. So if I'm just looking straight down onto the shipping container, I would see a rectangle. And we're trying to fit these boxes in it like this, so it fit them all in nicely. Now we know that along here we've got 6,000 millimetres, and this way here we've got 2,500 millimetres. So how many of these boxes can we fit along here? Well, it's going to be 6,000 divided by the length of the box, so 400. Which is 15. So we can fit 15 boxes along this way. And what about up this way? Well, the boxes are 500 millimetres deep, so we're going to need to divide that by 500. So we get 5. So if we want to draw this out again, let's do a quick sketch. We've got 5 boxes along this way, so 1, 2, 3, 4, 5, and then we're going to have 15 of them along this way. So if we want the total number of boxes on one level, it's going to be 15 times 5, or 5 times 15, which is 75 boxes, and that's on, let's say, on the base. So that's just one level. Okay, so say that comes up to here in the container. Now might be able to fit some more layers on as well. So we want to know how many layers can we fit. So now we've got to look at the height. So we know the height. I need some space for this. So height is 2,600 millimetres. Well, each individual box is 500, so we want to divide that by the 500, and that'll tell us how many boxes high we can go. And it's 5.2 boxes. But you can't fit 0.2 of a box in there, so we're just going to have to go with 5 boxes. So I'll put it down here. Total boxes in container will be our 75 that we can fit on one floor or one level, and multiply it by 5 because we've got 5 levels. So 5 times 75. Oh, I did something strange there. 5 times 75 is 375 boxes. Question 12. A company charges £3.50 a day to park at work. They decide to offer free parking for workers who share a car. The arrows on this map shows the route Joe usually takes to work. Okay, so here's Joe's house. They're telling us the usual route is in black, so she normally goes this way to work here. Now it looks like the route to pick up Alex is the red route, so that's the alternative route, which you can see looks a bit longer. Jo thinks she will save money if she picks Alex up on her way to work and takes her home. The total cost for petrol and other running costs for Jo's car is 25p for each mile she drives. Is Jo correct? Explain your answer, show workings to support your decision. Right, so what we want to do is work out the two distances, and then we're interested in the difference between them and the cost of that extra difference. Because we can use this 25p per mile to work out the cost for the extra distance, and then we're going to compare that to the £3.50 a day that she saves. Okay, so let's start off by working out the routes. So scale, we're told that one of these big boxes is 2 miles. So we got, that'll be 2, 2, 2 here, 2 for that, 2, 2, and another 2 here, and 2 for this section, another 2 there. And then this is just half a box, so that's just going to be 1. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So this is 19 miles. And now we're looking at the red route. So again, each of these is 2. So 2, another 2, 2, 2 here, 2, 2, 2, 2, 2, 2 miles, 2 miles. And we're going up for 2 miles. And this is just 1 again because it's half of one of those big boxes. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. So you could work out the cost of each of them and then subtract them, but I'm going to just work out the difference first of all. So the difference in distance is going to be 25 minus 19, because we're only interested in the extra cost. So 25 minus 19 is 6 miles. Okay, and it's 25p for each mile. So we want 6 times 25p. 6 times 25 is 150p, or divide it by 100, that's £1.50. We need to add the 0 because it's pounds and pence. Now that's just going to work. She's got to take her home as well. So we want to multiply that by 2. So 1.5 times 2 gives us £3. But the company normally charges £3.50. So £3 is less than £3.50. So will she save money? Yes, only 50p. So we sort of worked it out above. So we can say the additional costs would be £3, which is less than the £3.50 saved. Question 13. A farmer has a fence around this space. The space is symmetrical. Okay, so we've got some measurements written on there. Then we're told the fence is 2 meters high and goes all around the space, apart from a 1 meter gap for the gate in here. The fence needs painting on one side. And leave that up. Each litre of paint covers 5 metres squared. Okay, but we've got these tins here of 9 litres of paint for £19. What will be the cost of the paint the farmer must buy? Explain your decision. Right, so we've got to work out a few things. This is 6 marks, this question, so a lot to do. So the first thing we want to do is work out the perimeter, but ignoring the gate, okay? We then need to use the height to tell us the area of the fence. We then work out how many tins of paint we're going to need for that, and then we're going to work out the cost. So let's start at this corner here. So if that's 5 metres, that's also going to be 5 metres. So we've got 5. In fact, I'm going to write it out. We've got 5 plus 8.5 plus 5 down here plus 3 plus, well, this is going to be the same as over there because they said it's symmetrical. So plus 2 plus, well, this distance here, we don't know this one. We know that all the way across the top is 8.5. So it's going to be 8.5, but we don't want this bit on the left, minus 3, and we don't want this bit on the right, and we don't want the gate in the middle. So if we do our 8.5 minus a 3, minus another 3, minus 1 for the gate. Oh, so let's try that again. 8.5 minus 3, minus another 3, minus 1 for the gate. Gives us 1.5 metres. Okay, so we're going to add on a 1.5. That's going to be these two sections together. Then add on 2 here. And 3 metres to get us back to where we started. So we've got 5 plus 8.5 plus 5 plus 3 plus 2 plus 1.5 plus 2 plus 3 gives us 30 metres. But we want the area. So the area is going to be the perimeter, which is like the total length of the fence, multiplied by the height. So that gives us 60 metres squared. Okay, each litre of paint covers 5 metres squared. So if we do 60 divided by 5, this is going to tell us how many litres of paint we need, which is 12 litres of paint. And if each tin has got 9 litres, well, if we do 12 divided by 9, that will tell us how many tins we need, which is 1.33333. But you can't buy 0.333 of a tin, so we need 2 tins. They're £19 each. 2 times 19 is £38. And we can put that in here. Now there's not a great deal of space on here to show your workings, so you might want to use some scrap paper, but make sure if you do, you get all of your important workings out on here as well. Question 14. A supervisor needs to put a chart in a report about how long it took an engineer to repair a machine each time it had a fault last week. The supervisor wants to put the times into 3 suitable groups and use the grouped information to draw a chart. The supervisor finds the times for each fault. So 2 minutes, 16 minutes, 5 minutes, 7 minutes, and so on. It then says draw a pie chart for the supervisor's report. But before we do the pie chart, we've got to do our grouped data. So we also know that this is 6 marks, this question in total. That includes the drawing the pie chart. So you can think maybe that's about half the marks for the table we're going to draw, for the grouped information, and then the same for the pie chart. So we've got to decide what our groups are going to be. So we can put our time in minutes. Well, the highest value we've got is 25. So we've got some in single digits, some into the teens, some in the 20s. So I'm going to split it into groups of 10. So I'm going to say between 1 and 10 minutes, between 11 and 20 minutes, between 21 and 30 minutes. Okay, so long as your groups are the same size, it should be fine. So now we want to count how many we've got in each category. So how many are between 1 and 10 minutes? So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 of those. That's going to be our frequency. How many between 11 and 20? 1, 2, 3, 4, 5, 6. And how many between 21 and 30? 1, 2, 2. Okay. Right, now let's do a total for these. So we've got 16 of them in total. Now we're doing a pie chart, so we want to work out our angles, our degrees. Now we need those to add up to 360. So we want to work out how much each of these is worth in degrees. In other words, if we do 360 divided by 16, and we get 22.5 degrees. That's for each one machine. So if we want to find out the angles for the 8, well, we're going to do 8 times 22.5. And we get that it's 180 degrees. Now, hopefully you remember that 180 degrees is half of a circle. Well, 8 is half of 16. So that's great. We'd expect it to be 180 degrees. Okay, so that's a nice little check there as well. So we're going to multiply these by 22.5 as well. So 6 times 22.5 gives us 135 degrees. And 2 times 22.5 gives us 45 degrees. And we can check if we do 180 plus 135 plus 45, it gives us 360 degrees. Right, we've done all our calculations. Now we need to draw our pie chart. So we had 180 degrees for our first category. We're allowed to use a protractor, but we don't need to here because 180 degrees, we just go straight down the middle. And this was our first category, which was 1 to 10 minutes. Then the next group was 135 degrees. If you've got a protractor, that's excellent. But if you think, well, I know a right angle, that would be 90 degrees to there. So if we've got 135 minus 90, we get 45. Okay. Well, in fact, 45 is 2 lots of 45 makes 90. So it's going to be half of one here. Sorry if that was a bit of a complicated explanation. So instead, let's just show you on here. 135 degrees. If we start on 0 here, we go all the way around. Oh, I'll wobble that a bit. Till we get 135 degrees, which is here. So this is going to be our 11 to 20 minutes. And the last bit, which should be 45 degrees, and if we start reading from here now, we'll see it is. This is our 21 to 30 minutes. So I tried to show how you could do it without a protractor. Maybe complicated it, but it would be possible if you didn't have one. Okay, you just want to know your angles. 180 degrees all the way around a circle, 90 for a right angle, and that means that half of one of these is going to be 45 degrees. And now we're on to the last question. Question 15. A garage manager needs to write a report for head office. Head office asks the manager to include the average number of cars sold each month last year and the range of sales for the year. The table below shows the number of cars the garage sold each month last year. Find the information that head office needs. Comment on what your results show about the sales of cars last year. This is for 6 marks. So we want the average and we want the range. Okay, the average, particularly when it's level 1, means the mean. And then we calculate the mean by working out the total and dividing it by the frequency. So the total, we want to add up all of these values. So let's go to our calculator. So we're going to have 7 plus 17 plus 27 plus 22 plus 15 plus 18 plus 24 plus 16 plus 36 plus 27 plus 23 plus 8 gives us 240. And our frequency, well, we can count these, but it's for a year, so we should have 9, 10, 11, 12 months. So 240 divided by 12 means an average of 20. Okay, we've got the average. Now we want the range. Well, the way we calculate the range is by taking the biggest value and subtracting the smallest. So what's the biggest value? 27 maybe? No, 36 is higher. So that's our biggest. What's the smallest? 7. So it's going to be 36 minus 7. Which is 29 cars. So we can put that down here now. So we had an average of 20, a range of 29. We want a comment about the average and a comment about the range. So you don't want to overthink it too much. Just, well, we've got an average of 20. So if we maybe look at the month that's closest to 20, April. Yeah, so April was the month with sales closest to the average. Yeah, maybe you could say how many months were less than the average or how many were more, something like that. And then we've also got comment about the range. Well, it's quite a big range if you think the average is only 20. So maybe we can look at, or maybe we can say what the months were. So something along the lines of, there was a big variation in the minimum and maximum number of cars sold. That's what the range means. It's the variation between the minimum and maximum. With most sold in September and the fewest sold in, where was the lowest? In January. So those wordy questions can take a little bit of time, a little bit of thought. What I say is don't spend too much time on them. Try and get something down and then see if you've got time at the end to then go over them. Because chances are that the wordy bits are probably going to be 1 mark, but they might take more than 1 mark's worth of time to think about them. So just use your time carefully. Okay, so that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to my channel, turn your notifications on to find out when I add more videos, and I look forward to seeing you again soon. Thank you.